Okay, so fractional indices can actually get more complicated than just being something to the power of a half or something to the power of a third. Generally they're referred to as the nth root. So if you see something like this, nth root of x, it's equal to x to the power of 1 over n, and we already saw before that x to the power of a half equals the square root of x, and x to the power of a third equals the cube root of x. So it's not really a surprise that this is the general format for that. Okay, so it does get, it can get quite complicated, and you've got to remember some of the rules you know from using fractions and also from using other index laws to be able to answer all of these questions. So for example, if you had, say, a over b, and you had that and it was to the root of 7, then if you needed to rewrite that as a power instead of as a root, then you would write it like this: a over b in brackets to the power of 1/7. Okay, so if you get asked to write it without surds, then this is what you do. If something's got this on it, that means it's a surd, whatever this power happens to be in here. Okay, so if you get asked to do it without surds, change it to a fractional power like that. Pretty straightforward, isn't it? Okay, now it can get more complicated though. So for example, if I had a to the power of 2/3, what am I going to do here? Because if it was just 1/3, I would put you know, a square root symbol there, or a surd symbol, and put a 3 here and make it a cube root. But there's that 2 there as well, so we've got to deal with both of those things. Now, if I work through this, I know that this is also equal to a to the power of 2 to the power of 1/3. How do I know that? Because that is the same as a to the power of 2 times 1/3. Remember from the index laws earlier, if you have a power to another power, you multiply them together. So because this is true, 2 times 1/3 equals 2/3, then I can rearrange it to say a to the power of 2 equals to the power of 1/3 is the same as a to the power of 2/3. So what would I do from there? Well, that is pretty much how I could leave it. Although, oopsies, just rub that out. We don't really need that now. I'll just put that in a box. Okay, so from here, what could I do with that? I could write it like this. I could say that that's equal to a squared, and I could say it's equal to the cube root of a squared. That's getting that 1/3 and putting it here. So if you get given a question like this and you get asked to rewrite it without a fractional index, then you can take this step here of separating out the numerator from the denominator. If you put the numerator in there and you put the keep the denominator up here as a unit fraction, that multiplied by that is the same as that. And so we haven't really changed the value of it, we've just rearranged things. Taking that one step further from here down to here, I've kept the a squared, but I've put it in a cube root. So I hope that makes a little bit of sense. Let's try one more. What about if I had a to the power of minus 3/7? Okay, so not only do I have a fractional index up here, but it's also a negative index. So I have to think about this a little bit. I can repeat the process from before, more or less. I can say, well, that's going to be equal to a to the power of minus 3 to the power of 1/7. So you can see what I've done here. I've taken that denominator and I've kept it over here with a unit fraction, and I have taken the minus 3 from the numerator and I've put it down inside here. So following the same steps as I did back over here. So what will I do next? Next I'm going to have to now change this here to make it into a non-negative index. So that'd be 1 over a to the power of 3 to the power of 1/7. So do you see what I've done? Minus 3 as a power is the same as 1 over the positive power, a to the power of 3. Moving right along from there, I can now bring in the third symbol here. 1 over a to the power of 3 root 7 like this. Now if you ever have something like this with a root symbol outside of a fraction, then that's actually getting applied to the top and it's getting applied to the bottom. The nth root of 1 is just going to be 1, because 1 times 1 times 1 times 1 times 1 times 1 equals 1. So that just simplifies to be 1 over root 7 of a cubed. It looks complicated, doesn't it? But it's really just following the steps you've already learned in the index laws. Okay, good luck with that. Bye.